Programming Throwdown, episode 52, Scientific Python. Take it away, Patrick.
Virtual reality. When we're recording this podcast, we're, I think, just after the Game Developers Conference, and so there's been a lot of tech news buzz about virtual reality and all of the cool, awesome demos people have of their games and projects that run in virtual reality. So I thought this would be a good opportunity to talk about it. Personally, I've never gotten the chance to use any of the new generation, the Vive or I guess Sony has one now, or the Oculus Rift. But I hear it's a very awesome experience, and I'm starting to see like videos that make me excited to try it. And I know virtual reality is always supposed to have been the next big thing for a while now. But I feel like it might actually happen this time, or maybe it'll just fizzle and then they'll give up on it forever. Jason, have you actually gotten to try any virtual reality headsets?
I have. I tried the Oculus. It's pretty cool. One of the big things that I think I'm still waiting for. I mean, I'm obviously a huge gamer, right? And so the gaming part of it, I think is cool. But what I really want is actually a way to like produce content, VR content. I mean, right now, almost all the content is synthetic. It's all video games, rendered. But it'd be amazing if, you could just like set up a bunch of cameras in your living room and then, put your newborn baby or toddler or something in the living room, and your parents could just kind of walk around. Like, your parents would be maybe in, Australia or something, but they could walk around the living room.
So, but doesn't that require either like a robot or something like computational photography? Like you're taking a light field picture or whatever, some weird multi-camera pictures, and then computationally adjusting for a virtual camera location?
Yeah, I mean, what I'm envisioning
sounds awesome,
is,
but
like, what I envision is like you put a bunch of cameras in your living room, and then they build like a 3D representation of the living room, including like the table and everything. Yeah, I don't really know much about how that would actually work, but yeah, I'm sorry, I'm like kind of making up the technology, but I just want the ability for the content to be real instead of synthetic.
So you tried the Oculus Rift, and one of the things about, at least I think, but currently about the Oculus Rift is it tracks where your head is, but you can't like if you get up and walk forward, it doesn't know you walked forward.
Right.
Okay, and then the difference between the Vive, and I had to look it up, that's how it was pronounced, like Vive. The HTC Vive, is it actually has cameras in the room that track where you are, so you can actually like lean, move left, like strafe left and strafe right, walk forward.
Oh, really?
Yeah. And then like it puts up, or at least in the demo I was seeing, like it was putting up indications when you got close to your actual wall. Like you teach it the boundaries of your space.
Oh,
and then,
so you don't run into the wall.
Yeah, because you can't see, right? Because it's not augmented reality, it's actual virtual reality.
Right.
And so I think that's kind of cool, but that's going to be a drastic change, right? Because, I don't have as much time as I used to. But I remember being able to play for just hours and hours at a time. But if you're standing up, obviously, like that would probably get tired because, let's face it, I don't think most gamers are in shape.
I mean, there are other games like there's, DDR where you have to like stomp on some foot pedals. There's the Wii. In the Wii, you kind of have to be standing. So, I do think that there have been in the past
That's
games
true.
where...
But do people play them
active.
in the same amount of hours as like a Skyrim?
Oh, no, probably not, right?
I mean, maybe DDR,
so.
like a very, very few amount of people over a long
yeah,
period.
DDR. I mean, I used to play DDR in college, and yeah, you realistically can't play for more than an hour. You're totally exhausted.
Huh. Wait, were you good?
I was decent.
I was terrible.
I mean, given the amount of hours I played, I definitely wouldn't let me put it this way. I didn't have DDR talent, but I played so much that I could eventually beat most of the songs on the hardest difficulty.
Oh wait, on the hardest difficulty, I don't think I even ever have played. Like I think I never lasted more than 10 seconds or whatever the.
Remember Max 300?
No.
It was 300 beats per minute. And it was the fastest song. I mean, now they have faster, but at the time it was the fastest song on the machine, on that version of the machine. And I beat it on hard once. It was sort of like my crowning DDR achievement. But yeah, so I do.
So will you be
virtual
buying
reality
the
would be
Oculus
cool.
Rift after your demo?
I definitely want to buy it. Yeah, it is $700, so that's something to think about. But I thought it was amazing. I played this game where you're in a turret, and it was kind of like perfect for the Oculus Rift because you're sitting in this turret, like this machine gun turret thing, and it can't move. It's just stationary. And it's sort of like Counter-Strike. Like most shooting games, you kind of imagine like imagine like those Time Crisis and these games in the arcade where you have a gun and you're pointing it at the screen and shooting, right? But in this case, it's kind of like Counter-Strike where you look around and it shoots in the middle of the screen, wherever that happens to be. And so it's like a little bit of time kind of getting used to that. But once I got used to it, it was awesome. I mean, it was a great experience. I definitely would get one. If it was $300, I wouldn't even think about it. But for $700,
well, and also I mean, this is other one of the controversial things is that you need a beefy PC to play it.
Yeah, that's true.
Because I
just upgraded my computer, not with the intention of VR, but just because it was getting so old it couldn't function anymore. And so it's just coincidence that I do actually have the right specs for it.
Oh, I do not.
Yeah, you have to have a brand new computer. Yeah.
So most of the demos seem to be first person, but I saw a demo from Game Developers Conference for a third person VR game where you ever played like Metal Gear Solid, where you're like, as you move into different, is it Metal Gear Solid? Yeah, where like you're in a scene, almost like a security camera, and then you move into the next scene and it kind of jumps, and except that you could kind of move the camera around with your head. So your head was tracking the security camera or whatever, but it was a fantasy game, not a sci-fi game. And basically like you could so your guy kind of starts on the left of the screen and then he kind of runs in the room to the right and you kind of have to track over to the right so you can still see him. And I thought that was kind of a nifty excuse for like why you're not moving around.
Yeah, right. That's cool. Yeah, I wonder if if instead of you sort of like instead of the camera sort of being first person as you said, but instead like when you look around you actually orbit. So in other words, like if I turn my head to the left, the camera actually just like swivels out. I wonder if that would be disorienting.
Yeah, it might be. All right, well I think we're on to the news.
Yeah, news. So the first news story I have is for all you students or teachers out there. I try and periodically give you good references for ways to sort of get some kind of free stuff. And Amazon has something called AWS Educate. In the past, we've done GitHub. There's a bunch of amazing free stuff you can get through them. We've done a variety of different sources. This one's pretty cool. It gives you $100 a year in free Amazon credit, which you can use to
AWS
have a server running. That's right, web services credit. So you can use that to have your own server in the cloud running all day for a whole year for free. If you're an educator, if you're a teacher or something like that, you actually get $200 to share amongst your class, and it's really cool. I mean, $100 actually goes a very long way in AWS. As I said, you can have a server running for a whole year. You could also do there's something called Common Crawl, which is a data set that spans the entire internet. So we've talked about this in the past. You can use Common Crawl to see how many times Patrick shows up in the internet and just count all the Patricks.
Yes,
there's a lot of Patricks.
They're not me.
So I
don't even think I rank. Even if you search my full name, I don't think I rank in Google.
No, you don't have a Twitter account. How can you rank? Do you have a Facebook or no?
Does it count unused and I don't know the login and yeah.
Okay, no.
Sort of.
But you have a LinkedIn, right?
I applied to Facebook once and I thought it would be a good idea to have a Facebook account.
Oh, that seems like a good idea, yeah.
No, so I had one when they came out when you still had to be at specific universities and I was still in university.
Oh, yeah. That's right.
And then I was like, nope, I actually don't want to relate to these people anymore. So I closed it. That was before like it was anyone except college students. And
right.
I think I'm remembering that correctly. Anyways, and then eventually like I went to recreate it, and it turned out like it's really hard to actually fully delete your Facebook account. And so it was like dormant or inactive or something, and so it reactivated, and I never bothered deactivating it again. But I never go on there.
Got it.
I'm an antisocial person.
You would not show up that often. But anyway,
I one time used Google Plus.
One time. So scanning, for all the Patricks on the whole internet, you have to scan all, I think it's like 200 terabytes of data, and it only costs, I think, like $14. So you can see how like you have incredible computational resources at your disposal for free if you get this. So it's called AWS Educate. If you're a student or a teacher, definitely go here, get your free credit, and check it out. It's awesome.
Awesome. It's a good word. MAME went open source, and the entire internet said, wait, wasn't it already open source?
Yeah, exactly.
But I think this is an interesting story, and I put it in here, I guess partly because of that. And I know, Jason, you may have more context for this, but when you get a bunch of people together and write code, there's actually a lot of legal implications, whether you mean for there to be or not. And who owns the code, who has a right to the code, and these kinds of things are always very confusing and tricky. And the one I always remember isn't really related to code. I'm trying to remember now. I guess the guy who helped design the Stormtrooper helmet for the original Star Wars, like it was unclear the contract and manner under which he got paid, whether he retained any licensing or any of the rights to Stormtrooper helmets. And like he and Lucasfilm, I guess, or whoever owns the rights to Star Wars, went back and forth with several lawsuits because he would make products or molds based off of those things that he made and claimed he had ownership to be able to do that, and they said he didn't. And it just reminds me how like complicated. Basically, if someone does work, whether you pay them or not for you, and produces something, like who owns the thing, any copies of the thing, the likeness of the thing, if you don't nail it down, can get really confusing. And that is sort of related, I think, to what happened in MAME, is that people developed under different assumptions, different licenses, and then to change it, you basically have to go back and get all of them to agree to it.
That's right. And there's some parts of MAME, I think it's actually the software scaler, if I remember correctly. So I'm a MAME developer. I've worked on it for a while. Actually, just a short tangent. I got a nastygram from PayPal today, and they said that basically it was from their brand integrity department. And so I have a donate page on MameHub, which is a fork of MAME that I maintain. And MameHub comes with a bunch of servers and infrastructure and everything. And so the donations just kind of keep the lights on. I don't actively work on it anymore, but there's still a community, and they maintain themselves financially through the donations. So PayPal basically said, look, anything having to do with emulators hurts our brand. They don't want to be associated with it. And so they put my account in this sort of restricted mode where I couldn't do anything until I removed the donate button from my website. Like they in the email, they said it's not illegal, like what you're doing. We don't think it's illegal or anything. We just don't want to be associated with it.
But is this a recent change? Or they just recently figured out about you?
Well, I mean, MameHub is reasonably popular. I wouldn't say it's hugely popular, but it's been going on. MameHub's been going on for about 6 years, and I've had the donate button almost the entire time. And I just got this nastygram today, and it's not like the volume of donations has increased or anything. Yeah. So,
weird.
Anyway, so the software scaler in MAME is GPL licensed. The person who wrote it wanted it to be GPL licensed, and so I think even now today that is still under a GPL license. But everything else in MAME has been moved to BSD, and as Patrick said, it literally came down to talking to every single contributor and getting them all to agree to change the license.
And so it was free to download before, but there were restrictions upon like using it in commercial works and
that's right. It was not allowed to be used in commercial works, and that's why Kind of a funny story. If you have a PS1, actually, or any PS, I guess, there was a PS1 game called Atari Arcade Classics. And if you plug a keyboard into your PlayStation and hit tab, you'll actually bring up the MAME debug menu. So it was like, blatantly obvious that they were just forked MAME, and they just built MAME for the PlayStation. And it turns out they did. They worked a special license out with the MAME team, and so a lot of people felt as if having that license forced Sony to pay us, like pay MAME, and set up an agreement to have a commercial fork of MAME. But the reality is, like, MAME is a pretty complicated beast. And so to do something like compile MAME for the PlayStation, you need like a ton of expertise and guidance and consulting. And so, making the license commercially compatible, doesn't mean that like the project won't get funded anymore. So you can do whatever you want with MAME now, commercially or otherwise, and that's a cool thing.
Licenses, confusing. This is why lawyers make a lot of money.
That's right, exactly. And this is why you should definitely, if you have anything to do with licensing, you should definitely have a lawyer involved.
And I think there are, what is it called, pro bono, like working for free. I think I've seen stuff before from lawyers willing to, help out with these kinds of open source things and questions around them.
Yep.
I may be making that up, but I've never tried to seek their services, and I don't know if those are people who you'd want their services or not, but I think I've seen it before, so there's always something to consider as well. I would like to talk a little bit about, this may be probably a little old by now, but I'm still really excited about it. And I actually tuned in and watched this. I feel like is going to be momentous, if it isn't already, which was AlphaGo playing the game of Go against Lee Sedol, which most people agree has been dominant, if not the world champion, for like about a decade, and will go down as like a famous Go player. And so AlphaGo playing him was a big deal. They would play.
Yeah, just so people know the context. So AlphaGo is a machine learning, an AI, that was playing Go against Lee Sedol, who's a human being who was arguably one of the top world Go players.
Yep.
And a computer was able to beat a person. Was it 4-1?
Yep, that's right. So they, interestingly, I don't know. I meant to look this up, but I don't know if it's the rules of Go or it's specifically here to avoid any funny business. That basically they said we'll play 5 games, it's best of 5, so 3 to win. But they said even if a person or the computer reaches 3 games, they'll play all 5 regardless. And so AlphaGo won the first 3 in a row, securing its victory for the entire thing. With $1 million on the line, which I think was put up by Google, who owns DeepMind, who wrote the AlphaGo program. But they donated $1 million to charity. But Lee Sedol would have won $1 million if he had won. But they won the first 3. Then Lee Sedol won the 4th one, and Google AlphaGo won the 5th one.
Right.
And the interesting thing here, there's actually many interesting facts. So one is that I tuned in live. So it was live in Korea, which here on the West Coast was like late in the evening, like 8 p.m., 9 p.m. Go games last a pretty long time, apparently.
I was definitely up till 2 a.m.
Yeah. The commentary they had, they did, in America, Go isn't very big, but everywhere else, well, in Asia, I guess, several countries in Asia, China, Korea, and I think Japan is pretty big, like really big. And so they're actually paid professionals playing Go. And so they had commentators there. They had like a press room around it, and they had commentary in English that I watched on the West Coast. And I thought it was just awesome to like watch it live, even though it was kind of weird, like seemed kind of nerdy. But I feel like I've always read about Kasparov and Deep Blue, and I felt like this was happening again, and I wanted to like say I watched it live.
Yeah, it was amazing. Just a few like things to note. So Lee Sedol, he gave a lot of commentary about the games and everything, and a few things he mentioned which I thought were fascinating and make sense when you think about it is humans, they pursue one initiative at a time. So, human might concentrate on one area of the board, and there's sort of this agreement, like, I mean, not officially, but, if I place a stone on the bottom left and there's some battle going on in the bottom left of the board, that's going to draw the attention of my opponent, and he's going to place a stone there, and then we're going to have a little battle on the bottom left of the board. But when you're playing against AlphaGo, it doesn't really care about what happened last move. It looks at the current state of the board and says, what am I going to do now? And then when it's its turn again, it does that process again. It starts over, looks at the current state of the board and says, like, what should I do now? And so it might have two battles going simultaneously on different ends of the board, and it just alternates between the two. And that was something that gave Lee Sedol incredible difficulty, was that, when that sort of social contract was broken, now he has to sort of constantly keep shifting gears. And he was actually, I don't remember exactly what he said, but it was something to the effect of, I really didn't enjoy playing these games.
Oh, I didn't see that comment.
Oh, yeah. He said something like, I really didn't enjoy playing these games because of this and the fact that it was just so mentally straining. And,
interesting.
It's super interesting.
So I think we talked about the architecture of AlphaGo a little bit in a previous podcast at some point when it was first kind of announced. But yeah, I mean, one of the things is it doing that, like, as an exploit to humans, right? Knowing that humans would have trouble would be interesting. I don't think they did that.
No, I don't think so either.
But yeah, I mean, people were saying that its moves were often very human-like, if that makes sense. I don't know enough about Go to be able to kind of understand what they're saying, but I guess it seemed like it was playing music humans could play. But yeah, like playing one side of the board and another, because it sees more opportunity there. Like, it isn't an impolite thing to do per se, but yeah, it's very challenging because you're kind of not expecting it to happen as a human.
That's right.
I could see
but
that.
Yeah, super fascinating. If you haven't, although it was streamed live, you can still go and watch it. I think it's on YouTube. Definitely check it out.
So
it's boring to watch it for 6 hours straight. So don't do that.
And even
because you already know what's going to happen.
And it's weird because even if you watch the 15-minute summary of a game, they don't play out the whole game, and it's more of like a Go strategy commentary. What they haven't done yet, or I haven't seen, is and what I wanted to watch when it was happening, but I guess it would have spoiled it a little, or maybe you couldn't have shown it to like Lee Sedol, for instance. But would have been, so AlphaGo has an assessment of how it thinks it's doing, right? A very actual number, as opposed to a human who just has a vague idea, I guess. And I would have been curious to see like a meter, AlphaGo showing what it currently believes its probability of winning is.
Oh, and see how that
move.
changes over time. They did do that for the one game it lost. They actually showed there's a certain move that Lee Sedol made. There's a certain
it made a
move
that was a mistake,
made.
right? Yeah.
That's right, and it thought it was a good move for actually several moves later, and then eventually it realized that it wasn't a good move, but it was too late.
Right. So that would be interesting for me to see. And then I guess there's two things I want to say. One is first that AlphaGo cited Jason, our wonderful co-host here on Programming Throwdown. So
yeah, short story.
You helped make history here.
Yeah, short story about that is the DeepMind deep learning paper started with a paper that played Atari before they moved on to Go, and they used Atari to kind of prove out their algorithm, and the Atari paper actually references a paper that has an algorithm called HyperNeat that I invented. So yeah, so this is one of the cool things about going into academia is kind of being a part of that.
Dare I say the only cool thing?
Yeah, probably. So I mean, they've done just an incredible amount of work over the past 10 years. And a lot of those people actually have been doing neural network work. Actually, David Silver, who's one of the heads of DeepMind, wrote a thing called NeuroGo, which is a neural network that plays Go, back in around 2003. And so he's been interested in neural networks that play Go for a very long time. And so
Interesting.
Yeah.
But one of the things that I find fascinating, the second thing, aside from the congratulations to Jason and beating the world champion, is, which I want to know if your program could beat it. No, I'm just kidding.
No, absolutely not.
Okay. But the interesting thing is the rate of progress. So like Jason was saying, we've been working on Go for a while as computer people, programmers, whatever. Jason took a stab at it. This guy's taking a stab at it. And AlphaGo previously had beaten the European champion, which is, I think, was a news article we talked about before. But in analysis of that game, so that guy, I guess, is approximately ranked about 1,000, is what I've seen. And Lisa Dahl is ranked currently, I think they were saying like number 2 or 3 currently. And they were saying, like, analysis of that game, they really saw a lot of flaws in the way it played. And in between there in the fall and now here, it was, I guess, late winter, early, not spring yet, but when he played, that improved so much that it went from being ranked, maybe slightly above 1,000 to all the way able to beat the world champion, or a world champion caliber person. And that rate of acceleration, like, a human could never, ever play enough games or learn enough in that time period, I don't think, in order to be able to progress that quickly.
That's right.
But,
sorry,
go ahead.
Oh, I was just going to say, it's they have an incredible amount of resources, and once they can get the computer kind of in the right direction, now it's the equivalent of thousands and thousands of human years of learning.
Yep. And, fascinating too is, like, even at the time, I guess Facebook had announced also that it was working on Go, that it was beating amateurs, and they thought about great things. Google came out, like, saying, hey, we beat the European champion. And then now, like, basically you have the equivalent, I guess. In some ways, actually, they did a lot of things to be... There's a lot of controversy around Garry Kasparov versus Deep Blue. And I think Google tried to do a lot of stuff to make sure there wouldn't be controversy if they won, which they eventually did.
Yep.
And so I think, I wonder in 5 years, 10 years, 20 years if we'll remember having watched those games live.
Yeah, I hope so. It is truly a historic moment. A lot of people are saying incredulous things that aren't true, like we're going to have Terminator now. Or,
I saw those.
Strong AI is around the corner. None of these things are true, but it's still cool.
Oh, that's an interesting point. We could talk about that. Maybe we should have we had an episode about artificial intelligence? I think we had one about machine learning.
Yeah, we should do an AI episode. It sounds like a good idea.
I'm sure I could
about
find
this,
someone. Like the difference between, like, what is strong AI and like why AlphaGo won't be able to control a Boston Dynamics robot.
I promise you guys out there, we'll do an AI episode, and I'll find somebody cool to come on the show.
Ooh, people though, so I guess that could happen.
Yeah, we'll do it.
All right, very awesome. But yeah, I hope we'll look back on this and, remember, I remember the day.
That's right.
Anyways.
Yeah, it is amazing. Yeah, it's a huge leap forward.
Time for
cool
book of the show.
Book of the show. My book of the show is Masterminds of Programming. And so this book is a collection of sort of interviews with programming language inventors and other people who are sort of pioneers in programming. It's actually recommended by Tim. I'm not going to say your last name, but Tim, thank you for the recommendation. And it looks like a phenomenal book. It's obviously very anecdotal by design. So don't pick up this book if you're trying to learn C++ or something like that. It's not a good reference, but I think it's a fascinating read, and so highly recommend it.
My book is Redshirts by John Scalzi, who in an interview, I guess, said that he writes science fiction your grandma might like to read. I don't know that my grandmother would care to read this book. But Redshirts, if you are a Star Trek fan, which I'm a pretty bad Star Trek fan, meaning not really a Star Trek fan. I don't not like it. I've just never really gotten into it.
The more I thought about it, because I happened to, this somehow came up the fact that I don't know anything about Star Trek. And I realized I don't really know anything about Star Trek. I still haven't seen all the Star Wars movies. When it comes to like nerd culture, I actually rank pretty poorly.
Wow,
the only thing I
those
really
are
have going for me is that I'm a gamer.
Babylon 5?
I've seen like one episode.
Oh. What is the other one? Oh, Battlestar Galactica?
I've heard of it, but that's it.
Oh, whoa, Jason.
I know.
This is kind of shameful.
It was really like a moment of self-actualization when I realized that as far as from a cultural perspective, the only nerd thing I have going for me is gaming.
And no, you have a lot of nerd things, dude. You were like a really good chess player for a while.
I'm roping all that
Go
together.
AI.
Yeah. So definitely the programming and the gaming, like board games, video games, card games, like that I'm just super into. But yeah, movies, TV shows, dress, like apparel and all of that. I still have to catch on to all that.
Wait, you are nerdy with apparel or not? I'm not sure what you mean.
Yeah.
So you dress well or you dress poorly? Because dressing poorly is a nerdy thing to do.
That's true. I guess what I want, like one area
completely
where
derailing. All right, Redshirts. So this is a reference to Star Trek, and they kind of what would happen if people who were in a non-franchise infringing version of Star Trek realized that some of the stuff happening was ridiculous. I think I stole that line from the book, or a very similar line.
Nice.
And kind of like, why is it that the navigator for the entire spaceship goes down to the surface of the planet to investigate a murder? Like, why?
Right.
Like, that doesn't make sense. And then also, like, people who go down to the planet die, like, really, really often. And if you're wearing a red shirt, you're almost guaranteed to get killed.
Oh, right, because they gave the red shirt, right?
Well, because the security team, I think, is the people wearing the red shirts. And so they were just kind of like, yeah, if you didn't have a name, you were going to die. And yeah, anyway, so there's all this, like, cheesy plot points. And what happens if the people kind of picked up that, like, wait a second, this doesn't seem statistically likely. So it's a really fun read. It's a funny book. I listen to it on Audible because I have a long commute. I always say I read the book, but I really listen to it. And this is recorded by Will Wheaton, which
nice.
who was on Star Trek.
That's right.
And so
who was he again?
Wesley Crusher.
That's right, Wesley Crusher.
And so it's kind of even more interesting to hear him voicing this, where it's not actually Star Trek, right? Because it can't be, because they didn't have the license. And so, and he's also just a funny person to listen to. So it was a really good fit for him to read this book. And so I like that. So even if I had read the book, I might have still listened to it just to hear him do the, like, emoting of the ridiculousness of some of this stuff. Yeah.
Yeah, Will Wheaton, by the way, he has an amazing channel on YouTube where he covers board games and video games. I think it's called Tabletop.
Yes.
Yeah, it's called Tabletop. So Will Wheaton's is awesome. So yeah, that sounds like an amazing audiobook.
And he also records Ready Player One, which is another book I've recommended, and people have written in and been like, that is an amazing book.
Yep.
So I like, and that has virtual reality in it. So
yeah, Ready Player One was amazing. I read it based on your recommendation, and I absolutely loved it.
Did you read it or you listened to it?
I read it.
Okay. Listening to it is even.
I have a long commute, but it is a shuttle. I'm on a shuttle, and so.
You don't have headphones?
So I read.
Anyways, well, if others of you have long commutes.
If given the choice, I would rather read. But if I have a long drive, then I would obviously. I can't read,
fair enough. Because you could do other stuff. You can be on your laptop. Yeah, okay. Or read. Okay, fair enough. But you're missing out. Anyways, if others of you, Audible is a sponsor of our podcast, and if you would like to have a free 1 month trial, which means you can get a credit, which is good for a book, you can go to www.audibletrial.com/programmingthrowdown, and they'll get you set up, and then we get a little bit of money to help support the show, and you can cancel it as soon as you pick out your book, and then they don't. I think you require a credit card, but once you cancel it, they won't charge your card. And if you want to keep it going, I actually pay out of my pocket for a monthly subscription, one book a month, and then they run a lot of sales and stuff. And so this is just a PSA for all the people out there with long commutes, because this does help me a lot. Like the book I'm listening to now, which I'll probably recommend next show, I'm really into, and it actually sounds stupid, but I want to get in my car so I can like listen to it. And when someone else rides with me, like I have to take my kids to the sitters, I'm like, oh, I can't listen to my book. And so it really does help. And they run a lot of good sales and stuff, so you can get even more than your one book by buying other books for discounted prices.
Nice.
And so I really enjoy it.
For people like me who would rather read the book, if you go to programmingthrowdown.com, we have links to our book of the show, and there's special links. If you use our links, then Amazon gives us a little kickback, and we also put that towards bandwidth and other sort of infrastructure stuff.
Yep. And to finish out shilling for ways you can support the show, which just listening to it and downloading is also a good way to support the show, telling your friends about it on that Facebook thing that I'm not on. Or I don't know if anyone's on Google Plus anymore. Like, you could do it on Google Plus. I still see people adding me on Google Plus, so I know you guys are out there still using Google Plus. Sorry that if I don't ever respond, because I never check it. But you can also support us on Patreon. And
that's right.
We have a campaign going on there, and you can get to it from our programmingthrowdown.com. And there, what happens is you can kind of sign up for like, hey, every time there's an episode, I want to give a few dollars per episode, and that helps support the show as well. Keeps it going.
That's right, and thank you so much for your support. That's sort of a big part of keeping this whole thing going. We do have pretty high costs, a ton of bandwidth. We use terabytes and terabytes of bandwidth.
Yep, and we are working on it. And several of you have written in with helpful suggestions and offers to help and stuff. And if we haven't gotten back to you, sorry. We actually we're doing pretty good. We keep sending the emails in. But if we don't reply right away, we apologize. We try to.
Yeah,
but
definitely.
some of them might slip through the cracks. Because
if you sent an email and we didn't reply, send another email in like a few weeks.
Hey, I'm mad at you.
Yeah, ping.
No, don't say I'm mad at you. Okay, anyways, tool of the show.
My tool of the show is Laverna. So, a tool of the show in the past has been NVAlt. And if you remember that episode, NVAlt is a way to keep notes. And it actually, you can write notes in a markdown format, and it has a preview mode where you can look at it in a pretty HTML rendering, lets you search through your notes. I found it awesome. I came into a situation where I needed something like NVAlt, but it would also work on Windows and Linux. And NVAlt is a OS X only tool. So I found Laverna, which is extremely similar. It has a web interface. Actually, no, sorry. It has a web interface, but it also has a native desktop interface. It has both. And same type of idea where you connect it to your Dropbox account, and it stores all of your notes on Dropbox. But it lets you write in Markdown, has full text search, all that cool stuff that NVAlt has. So if you like NVAlt and you want something that where you can access your notes, on your Linux box at home or what have you, check out Laverna. It's pretty awesome.
So there are lots of tools and lots of ways of doing this, but increasingly I'm intrigued by, I think it's Sandstorm. Is that the people doing it? The private cloud or whatever? But basically, like,
I haven't heard of this. Sandstorm?
Yeah, you can check it out. So I think it's basically kind of like Docker, but like for personal stuff as opposed to like server stuff.
Okay.
And they're moving along, and I'm not exactly sure how it all works. But basically, I think they're the closest. The idea that like you describing this or whatever. But I don't want to necessarily run it in a server at home, but I want like a server somewhere that I can pay to just however much I need or don't need. Like an Amazon web server, small one, or something where, like, hey, I want someone to host my notes. And so, like, I can just install essentially a program on my cloud server, but it's my stuff, my storage, I manage it. And, like, once I either buy the program to install or it's open source, like, I don't have to worry about the service shutting down or not working. It's my cloud, right? Like, it'd be like running a server at home to do all that stuff. only it's run somewhere else, and there's like a standard way of adding, like, it sounds bad, like an app store of like adding apps to your cloud, right?
I see.
Do you kind of see what I'm saying? Like, I feel like there's
Yeah,
something
I'm looking
there.
at the website now. It's basically like a layer on top of AWS, where instead of like AWS, for people to know, it's just like they'll give you a Linux machine and you can SSH into it, and it's just sitting in the cloud. It's always running. And under the hood, if that physical machine dies, they can actually freeze your AWS instance and then start it somewhere else. And so from your perspective, you just have a machine somewhere out there that's always on. And so, but the issue is you need to be like SSHing into the machine. You have to be kind of really low level. This looks like it's just a layer on top of that, where it's like you can just have an application running in the cloud.
Right.
Is
But
that a good
and
way
this
of
idea
explaining
about
it?
like having a standardized container as well, right? So that you can get to this kind of quote unquote app store where like, hey, someone releases, there's exactly like in your note editing. It's like, hey, I want to edit notes. I want to be able to go to the web and get to my notes. I want to be able to, have a client on my iPhone, on my Android phone, on my, OS X box that edits the notes, and they all go back to my cloud. That way I don't have to worry about like, hey, what happens if this free service decides to go down or start charging or whatever? Like it's mine, right? Like once I'm running this program, I control
that
it.
makes sense.
And if I use up all my storage, I just get more, right? Yeah, I don't know.
Yeah, very cool. Sandstorm. That's another. I'll add it to the tool of the show.
Sorry, that was a sidetrack.
No, I think it's awesome. I'm really glad you
I need
showed
to
this
look
me.
into it more. I haven't looked into it, but the idea is, I read it, and then it's like, I don't know if what I took away from Sandstorm is what it's actually for, but that's what stuck in my head, and then I've just been like having this idea in the back of my head.
Yeah, no, I mean, it's pretty much exactly what you described. It looks very cool.
So so that was nothing about Laverna. That could be my tool of the show. I spent a lot of time talking about it. I'll save my other one
All
for
right.
next time. So I don't know
Okay.
anything about Sandstorm, but it's my tool of the show because it sounds awesome. And
No,
it's
it
free,
looks-
and I
it
normally
looks-
do video games that
It
you have to
looks
pay
totally
for.
cool.
So my tool of the show is that you have to go do work and look up what Sandstorm is, and then like tell me that I'm crazy or awesome.
All right, now you know what to do. Email Patrick. You can find his email from the website and tell him whether he's cool, whether he, what was it? Doesn't know what he's
No,
talking
you don't
about
need to
or
tell me. I
awesome.
already know. I've been being told
All
it my
right.
whole life.
Today, so on to the
Scientific Python.
Scientific Python. So, we have a show on Python. Since then, we've done shows on MATLAB and R. And we're going to do a show on Julia. We've gotten tons of requests on that. And so I think it's good to talk about.
Oh, I want to say
this-
something on that. Two things. One, a lot of people have
Sure.
written in for like follow-up shows, like, version 2. And I think this kind of qualifies as that for Python,
Yep.
like
Yep.
going more in depth. So this is kind of the answer to that, and we'll start with Python. The second thing is like, you talked about like a lot of people writing about Julia, and that's right. And one of the things like Programming Throwdown, we do explore a lot of things. But one of the things I find most important is like critical mass of like community, and how that like with this Python discussion, one of the nice things about doing these things in Python is Python has critical mass. Like if you have a problem, chances are other people have also had the problem, and so you'll be able to find your answer very quickly.
That's right. That's right.
And so
if you
although we
need to
talk
do
about other stuff, because it's always good to keep abreast of other situations and have other tools in your bag, it is really nice to also pay attention to how much community there is behind a given thing.
Yep, and especially, by using Scientific Python, you're leveraging the general Python community. So if when you do any type of scientific analysis, you still have to do some integration work as well.
Or
So,
even stuff like I
maybe-
need to open a file, or
Yeah, or my data is in HDF5 format, and so I need a loader for that or something. Or I have to get my data from Hadoop or something, right? And so all of these things in general are much easier to do in Python than, say, like MATLAB or R or some other very specific kind of environment. So there's two main interfaces to doing scientific work in Python. One is the command line. So Keep in mind, so when I say scientific work, I'm talking about, analysis where
Working
you
with
want
data.
to, yeah, you have some data, you slice the data one way, you get some results, you slice the data another way, you get another result, and you're not really writing code that you're going to keep. I mean, you're writing scripts and you might want to keep it as a reference, but it's really you're trying to learn something about some data, and it usually involves a very fast iteration, trying many different things, learning a lot, and hopefully
And
what
often
comes out of it.
plotting or something, right? So
That's
like,
right. What comes out of it is some kind of visualization or
yeah,
several visualizations.
or a
So,
table or.
yep. So,
So that can involve like logs analysis too, right? Like, what is the most common time that people come to my website, right?
yep.
Yeah, so scientific doesn't just mean like collection of science experiments. That's a good point.
Yeah, totally, totally. So this is where this sort of data scientist term comes from. It's like, your weblogs can be sort of a medium by which you do this data science, and so it's not. Yeah, you're not talking about like protein analysis or something like that.
Although you could be.
Yeah, I mean it's greater scope than that. So it includes that, but also looking at your website and seeing how popular it is and things like that. So one interface is the command line. This is just where you type Python, you hit enter, and you get a prompt, and you can run all sorts of commands in there. That is okay, but there's several others that are better. So one is Spider, and this is
Yep, and that's with a Y.
Yeah.
Spider with a Y.
Yep, Spider with a Y. And this is actually similar to MATLAB. So if you're used to using MATLAB, I actually just started using Spider a week ago. Patrick mentioned it to me last week, and I checked it out. It's amazing. It gives you a nice MATLAB interface where you can see variables that you've most recently used. Just like in MATLAB, you can inspect them and things like that.
Well, I'm good. I'm glad I didn't send you down a rabbit trail.
No, it's totally awesome. It runs on your desktop just like MATLAB. There's also Jupyter, which used to be called IPython Notebook. Jupyter is very similar to Mathematica Notebook, if you've ever used that. Mathematica is another scientific computational platform. So the idea with the Mathematica Notebook and with Jupyter that's super awesome is, let's say you're doing some data analysis and you have different stages. The first stage, you're loading in data. The second stage, you're doing a bunch of transformations, right? And then the third stage, you're creating some visualization. So going back to Patrick's example, the first stage, you're loading all of your web logs from Apache. The second stage, you're computing some histogram, and it takes maybe an hour to compute a histogram and read all the logs.
We have a very popular website.
And then the third stage, you're plotting it, right? So let's say you plot it, and the plot, is correct, but it just doesn't look very good. Like maybe you want the line to be blue or something. You can actually rerun that third cell that generates the plot, and it can take the results from the second cell. So in other words, if you have your data broken up into these cells, every time you finish one cell, it sort of freezes everything and says, okay, I finished this cell, and the next time I need to run the cell after it, I know what to do, like where to start. And so you can tweak your plot 100 different times without having to run your entire code base. You can just run the plot part, which is really important.
The other important thing I think with the notebook style that can be really cool is that you often with programs, you just see the output, right? Like you just see, oh, here was my data set and here's the graph. And sometimes that's good. And you can get that from the notebook. But other times people want to see the process you went through, right? Or even intermediate graphs, like first the data looks like this, then I apply this filter and it looks like that.
Yep.
And seeing you kind of do that, like seeing the steps you go through, frozen and, visible and then even interactive in some ways, is really useful.
Yep. And some of the cells don't even have to be Python. You can actually have cells that are just text. So you can have a cell doing all sorts of computation, and then the next cell just describes what happened in the previous cell. And you can actually take your IPython notebook and send it to somebody, and now they have, your source code, potentially your data, and your documentation all in one file, which is pretty cool. So those are the interfaces. Now, most scientific libraries or scientific platforms have a tensor library. So what this means is, for people who don't know, a tensor is just a higher dimensional matrix. So, if you have sort of, let's say you have a point. So a point has X, Y, Z coordinates, like some point in 3D. So that would be a vector. That's also called a vector. And so this is one-dimensional array of numbers, X, Y, Z, right? You can have a matrix, which is 2 dimensions. So it has rows and columns, and each element is a cell, kind of like Excel spreadsheet is a matrix, right? But then you might need 3 dimensions of numbers, or 4 dimensions, or 5 dimensions. So these are called tensors. And so there are libraries out there that do tensor operations very fast. And this is often critical for any type of scientific computing. So the most popular is NumPy. NumPy is very similar to MATLAB. So if you have experience using MATLAB, or even if you have experience using R, you'll be right at home with NumPy. The thing to know about NumPy is it's super fast, and it's fast because you do operations on matrices or vectors. So in other words, let's say I have 2 vectors, 2 lists of numbers. I'll just call it list A and list B. And I want to add them, like I want to add each component of the list and produce a new list C. So if I write a for loop in Python, I just say for, 1 to a million, C of I equals A of I plus B of I. That's going to take a long time. I mean, that's going to take maybe a second. Even so for a million numbers, that's a long time. If you have, a gigabyte of data, it's going to take 3 days or something. It's going to take a super long time. But you don't have to do that. With NumPy, if they're NumPy arrays, you can literally just say C equals A plus B. And under the hood, it's going to turn that into super, super fast C code that's just going to blitz through that data. It's going to use special SIMD processors on your computer. And I mean, it's going to go from a second to so fast you can't even measure it, like less than a millisecond. So like, although people say Python is slow, and they're right. I mean, Python is definitely much slower than C in general. NumPy is just incredibly fast. And so you should never shy away from NumPy or from scientific Python for performance reasons.
I think to be a little more specific, fast is an arbitrary word, but like efficient, which would be like how many instructions it takes to do the same operation. And if you could do it in less, then that would be better, or quote unquote faster. But it still may be, I mean, if you're using big data, it could still take a long time.
That's true. Yep. Yeah, totally.
So maybe that's a little goofy, but fast here just means, like in Python, your CPU has to execute more instructions per line of Python than per line of C, as a vague general rule.
Right. So NumPy is there. There's Theano, which is built on top of NumPy and gives you GPU support. So we'll talk more about GPUs in the future. I think there's a lot we could cover there. But the short story is that GPUs and tensors go together really well. Like GPUs
are meant to do matrix operations.
Exactly. And so
moving the triangles around is all about matrix multiplying.
Yep. And so Theano will let you take your NumPy code, which is already fast, but it's running on your CPU, and it will let you run it on the GPU, and that can give you pretty dramatic speedups. Theano is a university project, and so documentation isn't great. It has a lot of sort of legacy code that's kind of ugly. So there's something called TensorFlow, which is a Google product It's totally free, and it solves the same use case as Theano, but has amazing documentation, very well documented. They have tutorials that are great for beginners, and so if someone was starting a new project now, I would definitely tell them to use TensorFlow. TensorFlow. Oh, go ahead.
No, I was just gonna ask. So TensorFlow, like you said, has a lot of matrix operations and stuff, but I always see, So is it machine learning also, right? So machine learning also gets into using a lot of matrices and matrix operations. And is TensorFlow designed to kind of handle that, or it handles both? Like it's more generic? I haven't actually looked into it.
Oh, sure. It's more generic.
Okay.
They do have libraries for machine learning. Even Theano has some functions that are, very sort of specific to machine learning. But you can use TensorFlow for anything. Yeah. So those are sort of the tensor libraries that will give you kind of that MATLAB or R kind of like performance. So some more scientific libraries to sort of help manipulate these matrices and these tensors in more complex ways. The most popular is SciPy. SciPy is also built on top of NumPy. It gives you things like integration. So if you have some distribution and you want to integrate it, you can do that. It does optimization. So if you have a set of points and you want to fit a curve to those points and you want to minimize the distance from the points to the curve, so you want that curve to be as close as possible to going through those points, it can do that. It has a bunch of signal processing like low pass filter, high pass filter, FFTs. Has a ton of these different systems.
Confusingly, some of those are in NumPy, but NumPy and SciPy are kind of joined at the hip, or at least in my mind. I don't know what the exact difference is.
That is
search is your friend.
Yeah, that's true. Definitely. You'll have to do a lot of Googling. That is one nice thing I would say. That's one sort of con of scientific Python is that because it's fragmented, there isn't just sort of one body that's saying, okay, here's how we're going to lay everything out. And so it does take a little bit of Googling to sort of get your hands wet. But yeah, SciPy is also statistics. If you want to draw from like a Poisson distribution, you want 100 numbers drawn from a Poisson distribution, there's just a one-liner that just gives that to you. It can give you, CDFs of distributions. Anything statistics related you need, SciPy can do it. It also has good sparse linear algebra libraries. So there are times where, let's say, for example, going back to the visiting your website, let's say you had some array where every second what the array contained a number of how many people visited your website that second. Well, a lot of those are going to be 0, depending on your website. But if your website isn't uber popular, a lot of those values will be 0. And so storing all these zeros or doing anything with all these zeros is going to be very expensive. So SciPy actually has a sparse linear algebra library. So it only stores the non-zeros. And when it does operations, it kind of understands sort of that structure. So if you add 2 arrays, it'll only add the non-zeros, things like that.
And this becomes critical in some branches of science because the matrices grow really, really big. So the thing I always remember about sparse, which is an interesting way, is if you think about Conway's Game of Life, and if you think about playing it on basically an arbitrarily large board, how would you how would you perform the operations I don't know, a lot of early programming courses kind of take you through implementing Conway's Game of Life, and you typically just use an array of arrays or a 2-dimensional array, and you kind of do it. But what would happen if the board was really, really, really big? How would you do it efficiently?
Right.
And that's always kind of one of the things that, in my mind, is a way I can relate that, because a lot of the science is out of reach for me. So,
yeah.
And it's just as Jason said, you basically only track and operate on the places which are non-zero, and the zeros just aren't even represented explicitly.
Yep. So And another thing is pandas. Pandas is pretty cool. If you've ever used R, you know what a data frame is. If not, I can explain it. A data frame is, think of it like a SQL database in memory. And so, if you've ever taken a SQL class, I think, we actually covered SQL on a previous show. So, in SQL, you might do something like select the username where the age is 18 and up. And so what you end up with is a list of all your 18 years and older users, right? So obviously it's super cool, but there's many times where you don't want to be using SQL. Like, you don't want to have to query your SQL database every time you want some data just because they have a nice interface, right? Because you have to go out to the network to get that data. It's kind of painful. So what would be amazing would be if you could have like a SQL database, but it's just sitting in memory. And when you do that select, it's just instantaneous, which is very quick because it's just really doing an in-memory lookup. And so that's what Pandas does. So with Pandas, you load your data into a data frame, and then you can do what's called pivoting, which is similar to doing kind of these select statements. And you can sort of slice and dice your data very quickly. Pandas also handles reading and writing in most formats. So once you have your data in a data frame, you can write it out to HTF5, you can write it out to a SQL script, to CSV, and it goes the other way too. You can take a whole SQL database that you serialize to CSV, to .SQL, and you can read it into a data frame using Pandas. So Pandas, if you're doing any type of data analysis, it's absolutely essential, and it's very well done. The last one is kind of specific. It's PyMC, and this is for Bayesian models. We've talked about accept reject sampling. We've talked about some other Bayesian methods in the past. So PyMC basically just makes this super easy, and it's pretty cool how it works. Like, one thing you can do is, if you want to, let's say you want to do some analysis on rolling a die. So if you had you just say, NumPy, give me a random number between 1 and 6, and it says 2. That doesn't really tell you anything. You just got one number. So you want to know sort of if you roll 2 dice, what that distribution looks like. If you roll 2 dice, how often you get 6 as on the sum versus 2, right? You could actually in PyMC you can say x equals random number from 1 to 6 plus random number from 1 to 6. And then you can say, it gives me a distribution of x. And it will just, run a bunch of calculations and show you what that looks like. So it's just super easy. You don't have to build crazy calculation. You don't have to deal with running the same parallel when all constants in. It does all that for you. You just write a bunch of equations with random numbers, and then at the end you just say, show me for the ways this answer can exist, and it just does like magic.
Almost always the output of all of this analysis is some sort of visualization. We already kind of said that. So one of the tools that's used to generate those visualizations is Matplotlib. It has almost identical, as far as I know, function parameters as MATLAB. And so you can, plot a graph, set the colors, set the weight of the line, set how you want the points used or drawn. And it's not particularly fast. So if you have like a dynamic signal, you wouldn't want to, plot it over and over again. It's kind of slow for doing that. But for plotting the results of a whole bunch of computation, like we've been talking about in this context, it works really well.
Yeah, you're totally right. Another cool visualization tool is Panoramics. So Panoramics is a little bit different. It's not a library, so it's not like while you're writing code, you just make a call to Panoramics. It doesn't really work that way. Instead, what you do is you export your data using something like Pandas, and then you have a panoramics service that's running, and you point it to your data, and then it will give you a bunch of visualizations. So the drawback is you can't just make a call into it. It's not lightweight. But on the flip side, it's very, very full featured. So you actually, if you specify the type of your data, so if you say, for example, these are latitude, longitude points, then it will actually generate a map using, I guess, Google Maps or something. It will actually generate a map, and it will put like hot areas on the map where you have a lot of points and cold areas where you don't, things like that. It'll generate a bunch of different charts and ways to slice and dice the data. It's really cool. So I highly recommend it.
Well, that's all I got for Scientific Python.
Yeah, so if you one thing to keep in mind is no matter what you choose to do with respect to programming or engineering, you'll eventually have to do this. I mean, if you build a website, you're eventually going to have to count how many people visit your website. I mean, if you're building it and trying to grow it. No matter what you do, you're going to need to do some type of analysis. And so, if you take a bit of time to learn scientific Python and this kind of stack, it'll be just incredibly valuable for anything that you want to do in the future.
And as Jason pointed out, often, and it's not always the case, but in my experience, often these are the things you want to know how to do quickly because this is throwaway code. Like it's code you write once and do the analysis, and then you next time you need to do the analysis, it will have changed significantly enough that you likely can't just run the same thing again. At least that's been my experience. And that comes down to a judgment call between writing something that you plan to maintain and that you want to be, let's call it well-written, and it's going to stay for a while, and something that you mean to build to produce an output and then destroy the process or whatever.
Yeah, you're totally right. So yeah, I mean, getting more adept at this increases like your productivity dramatically.
Yep. Well, thanks y'all for listening.
So, thank you for the feedback. We hope to do more interviews. A lot of the feedback we've gotten recently has been, the interviews are great, and we appreciate that. We are listening, and so we couldn't do an interview this month, and nor would we want to do an interview every single month. But we've had a lot of fun doing interviews, and
and I feel like we do it differently.
We hope to have an interview lined up next month.
That's right. And people have written in and kind of said, like, oh, more technical, or, oh, I like it this, less technical. But I mean, I think I've listened to other interview podcasts and things on the internet, and people get very technical or whatever, and that's cool. But I feel like we bring our own brand of interviewing by kind of keeping it light, but also technical, right? And hopefully, these are the kind of conversations that I have with Jason, or the kind of conversations I have at work. So maybe you enjoy that. Maybe you would be like, dude, it'd be cool to work with Patrick and Jason. Or maybe you're like, no, I hate these guys. Like, they must not get any work done. You're probably right. Or if you're in school and you're like, hey, what is it like to, kind of be on a team of programming or a team doing programming aside from the actual programming? Hopefully we bring that to your lives.
Yeah, absolutely. I mean, one thing that's kind of obvious and obvious to people who have been in industry a while is that what your job is definitely not what you expect it to be when you're in college. And I mean, this is true of any job. I mean, look at, say, basketball player. A basketball player spends a ton of time doing like autographs, agents, doing all these different like book signing or t-shirt signings, all this stuff.
And even more than that, and like a lot of time just practicing, right? So you think of a basketball player as just playing the game, like that you see on TV. But in reality, they play practice games. They do all that stuff you said. They talk strategy. You're right. But even when they're playing basketball, they're not playing the kind of basketball you typically think about.
That's right. Exactly. And so hopefully we give you a taste of sort of what we do day to day, and that kind of helps you to understand sort of what you're in for once you do program, if you're not already doing it for a career.
So I finally had a coworker tell me that they this is a while ago, tell me that they listen to the podcast and they think it's awesome because it's like a conversation with me, but they don't have to participate.
That's fine.
Okay. So if you're listening, you know who you are. And
I don't know if that's a backhanded compliment. It's
no,
almost like
I think they said they like, it's
sideways
something they like
compliment.
listening to in the background because it's just kind of casual and they know me and they know my taste and they know where I'm going to go.
Nice. That's awesome.
So,
yeah, well,
hello, mysterious coworker.
Keep sending us emails with the feedback and everything. We do appreciate it. As Patrick said, we've answered hopefully all of them. If not, send us another one, another email. And really look forward to hearing what you think about this episode.
All right. Till next time.
Cool. See you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.